Welcome everyone. I'm Benjamin Cabe. I'm with the Eclipse Foundation. I'm in Toulouse, France, as I speak, and I'm happy to spend some time with you guys to tell you about what's going on at Eclipse around IoT and what open source projects we have that allow people to build Internet of Things solutions. So I have I don't know, something like 40 or 50 slides covering some ground about what we have. I hope you will be interrupting me anytime with questions, and I will make sure to pose quite often to ask you guys for questions and feedback. I don't see, given that I'm sharing my desktop full screen, I won't be seeing anything from the chat. So yeah, please just make yourself heard with any questions you may have. So not spending too much time on that, but just want to make sure that we are on the same page when it comes to sort of a definition of IoT, or more specifically, what really matters when one builds an IoT solution. For me, it is not about creating or building connected gadgets just for the sake of creating connected gadgets, right? Putting an IoT collar around your dog's neck, I don't think it's that useful. What is maybe more useful is if you start thinking, well, what if I was able to monitor the intake of food for my pet during the day, right? So think about an application first, and then, yes, it's going to be, you're going to want to collect some data, some meaningful data that's going to allow you to solve an actual problem, right? And so there, you start thinking applications, and yes, at some point you will need to put sensors on them that will allow you to sense the physical world, and maybe you will indeed create a connected dog collar or whatever other kind of connected device. And between the physical world and the application is going to be a whole lot of techniques for basically bridging the physical world to the internet. Some of those techniques might be IT as usual and basically just good old internet. Some of those techniques and practices might be more new and really specific to the IoT, in that they will be specific to the fact that we'll deal with sensors, with constrained devices, with large amounts of data. So that's basically sort of my definition of IoT, and just kind of a reminder that it should be applications first, rather than thinking just, yeah, let's create some crazy gadgets. So a typical IoT architectures, from a very probably very much simplified architecture, but just to make sure we are talking about the same kind of concepts here, or at least maybe you will have synonyms for some of the terms I will use. I will basically focus on three different pieces when it comes to building the applications that I was mentioning just before. Those applications, like basically making use of the data that we will be collecting, and or those applications being able to interact and to send commands, instructions to the devices on the field. Well, what happens before data makes its way to the applications? Well, first are the devices, right? The sensors, the actuators that will allow me to interact with the physical world. Those devices, those equipment will very likely not be able to directly communicate with the internet. So by means of gateways, we'll be able to basically create a bridge between those constrained devices and the the world of IP, basically of internet protocols and a good old internet. So that's what the gateways will be for. Just for completeness, you will realize that some, at least in my mind, some devices, I would call them like they are de facto gateways or smart objects, if you will, in that yes, they are able to interact with the physical world, and they are in practice sensors and actuators, but they are smart enough so that they can effectively connect to the internet. So they are kind of in between a device and a gateway. And then comes the cloud, and we'll see sort of the roles and responsibilities of the three parts: the devices, the gateways, and the cloud. But essentially, what I call the cloud platform is where all the data will end up. In addition to this is where we'll be able to manage our fleet of devices and gateways. This is where we will deal with the device identity, device security, etc., etc. So several sort of services will be part of the IoT cloud. Going further in terms of sort of the typical not only roles and responsibilities of the device, the gateway, and the cloud platform, but also the key characteristics. When I say device, and later on when I will tell you guys about some of the open source projects we have that are relevant and that are targeting so-called devices, I'm thinking first constrained as in limited computing capabilities, like processing power, limited memory, very much constrained. Low power, it doesn't have to be low power, but more and more we see those constrained devices also. One reason a device is constrained is, well, there's really several actually. One is the cost, right? When you build an IoT solution and there's thousands or millions of sensors in the field, and like when we talk about billion of devices for the IoT, this is what we're talking about, right? The sensors. So when you can save a fraction of a euro by means of getting rid of a couple kilobytes of RAM or something like that, you will certainly do it. The device typically will have to have a fairly small form factor, so that also comes with constraints in terms of how powerful the device can be, and the device very likely will have to live on off the grid one way or the other, so very low power consumption. And I guess it all boils down to the specialization when you decide what sensor, what actuator you will put on your onto your connected thing, your connected object. You will make choices in terms of what protocols you want to support, what kind of capabilities you want, and you will be very much specialized, right? You will make choices in terms of what the device does, so as to save on the cost, so as to save on the power consumption. And essentially, when you start thinking software as opposed to hardware, what software you will put on the device, well, you will be limited to the underlying capabilities of the device. But that's actually what we want. We want to save on the cost overall, right? Moving on to the gateways and the smart objects. So the idea is really to sort of bridge the physical world to the internet, like I said earlier. And so it's all going to be about the connectivity. When you think device, you think about sensing the physical world, and you will have sensors that basically get some very raw, simple, atomic, if you will, information from the field. You need to sort of route this information to the internet. So first is the connectivity. So the gateway will support typically several protocols, several internet protocols, several radio protocols. Maybe you will do Wi-Fi together with Bluetooth, together with cellular, etc., etc. And also in terms more of the information that will go through the gateway, as opposed to, like I said, very simple information that you get from your sensors. At the gateway level, you will start thinking in terms of messages, like you get a temperature out of a device, a constrained device. When the gateway starts collecting the information from various sensors, maybe the raw temperature information will be turned into something more meaningful in terms of maybe, okay, this is a temperature, yes, it's 21.3 Celsius, but maybe the gateway will have the intelligence and the required software that will turn this information into something like it's too warm or it's too cold, and like the ability to take decisions based on those this higher level information, if you will. And all in all, this means enabling so-called edge computing, that is putting intelligence at the edge of the network, like before sending data from some people actually call it fog computing, as opposed to the cloud, which sits high up, well, in the cloud. If you go a bit lower in terms of sort of altitude, well, the fog lies really at the bottom of your network infrastructure, and rather than sending millions of data points per minute from your gateway to the cloud, maybe you have some intelligence at the edge, intelligence at the gateway level, so that you can take actions without like putting too much load on your network overall. Moving on to the cloud, the typical things to keep in mind when it comes to the IoT cloud platform is the scalability aspect. Well, of course, when you think IT and computer science, like we all know it, scalability is always sort of a thing to keep in mind, but even more so with IoT, because there's first the sort of horizontal scalability in that there will be lots of information coming into the platform from the field, and when you start scaling from one smart thermostat or whatever is your connected device to 10 to 100 to 2 millions, well, you will need to scale your cloud backend horizontally as well as probably vertically, in that the whatever intelligence you deploy in your cloud backend, whatever services or microservices, if you will, you deploy, they will need to cope with the variety of use cases, right? It's not necessarily the same to have an IoT, a time series database for your IoT data that's able to deal with data coming from home automation scenario, and data that comes from a connected factory, a smart plant, a smart factory. The data points will be probably very different in that for a connected factory, the data might be coming from many different devices, some of them being 30 years old, and like the data will be very heterogeneous. The frequency at which the data is being collected will be probably very, very different in a factory versus a connected home, where the data, like maybe an update rate of a minute is okay, whereas a connected factory, maybe you need to acquire data every millisecond, right? So having software components that are able to address, if possible, such a variety of use cases is important, in addition to the ability to integrate with third-party systems. What do I mean by that? Well, we will see what are some of the core services required on an IoT backend. but it's yeah, it's likely that you will need to, like, you want the IoT cloud platform to make the data available, and then it's going to be your job as a sort of an integrator to leverage all this information. So all kinds of APIs will need to be exposed, right, by the cloud backend. And all in all, it's probably going to be all about like data analytics, big data, call it whatever you want, but the IoT cloud platform will need to have some capabilities in terms of making sense of all the data that's coming from the field. So we went through the mental exercise, if you will, at Eclipse IoT to try and identify for each stack, for each basically part of an IoT solution, the devices, the gateways, and the cloud, what are the typical software components and functional blocks that need to be deployed in each of these parts. And I will be diving a bit deeper into all of those, keeping in mind also that yes, like for each of those, there will be some key concerns, as well as some cross-layer concerns. Actually, like you don't see security appearing in any of these stacks. Well, the reason is security is all over, right? You need security when you build your devices. You need to secure your communications either at the gateway level or the cloud level. You need to manage the identity, etc. So it's really all over, and so is also our data semantics, as well as the everything tools, IDEs, SDKs. That's what we'll see just now. So for the devices, what are the sort of the key the key aspects, the key components when you build? So again, the constrained device is your sensor, to put it to make it short, your connected device that's very likely not able to directly talk to an internet cloud directly. So when you build your constrained device, you will basically get, so think Arduino, right, or an ARM Cortex microcontroller. We're really talking microcontroller here. So when you get your microcontroller from ARM, ST Micro, Atmel, whoever else, you might probably have some kind of real-time operating system. You might not actually. It might be bare metal, and you might be like developing your code directly against the silicon, if you will. But there might be some kind of abstraction of what is a file system, what is like the ability to do concurrent programming and that kind of stuff, but probably not much, right? Another component that you might find, or at least you might require, is some kind of hardware abstraction layer. So by that I mean, when you build a solution at day one, you might realize that, well, yes, this chip from ST Microelectronic seems to do the job and is cheap enough and has all the capabilities you require. So we will start writing software against and for this particular device. Later on, you might realize that there is a better chip out there that's even more inexpensive, etc., etc. So you will want to port your code. And so is there a way that our IoT applications, like those apps that will basically run on top of our constrained devices, is there a way to make them portable? So we'll see if what's available out there, and possibly at Eclipse, to have some kind of hardware abstraction layer. Another important aspect of building an IoT application on your microcontroller is the ability to have support for some protocols, communication protocols that are going to be useful for building an IoT application. So we're not talking IP, we're not talking internet. Again, like I'm really talking super constrained devices. I think in 5 years' time, it's very likely that what we call constrained devices today, like the line will become more and more blurry between what is a constrained device and what is sort of a gateway or a device that can talk directly IP. Today, there's still a difference, right, between very constrained devices, like maybe they cost 10 cents and they really don't know how to do internet, versus those slightly more powerful devices that can do internet. So when they can't do internet, IoT microcontrollers, IoT devices still must come with some kind of support for protocols like Bluetooth. Maybe we're talking Z-Wave, Thread, if we're connecting our constrained equipment in a car. Maybe we're going to talk CAN bus, etc., etc. You can actually see that I already anticipate on the line being blurry, since we also see some constrained devices that have some kind of internet connectivity because they are actually able to start talking directly IP protocols like MQTT or CoAP. Last but not least, when it comes to a constrained device, is the remote management capability, and that's actually probably pretty unique, or that comes with IoT use cases. Like we've been doing and using microcontrollers pretty much since computers were invented, right? One thing that's new though is that when you start deploying devices in the field where there's no human anywhere near the devices, and there's no human machine interface whatsoever with those equipment, there needs to be a way to deploy new software and software updates over the air to those devices, so that you can fix vulnerabilities, so you can deploy new firmware upgrades to add new functionality, so that in general you can basically monitor the health of your fleet, right? So exposing remote management capabilities from your constrained devices is actually a very important aspect of your constrained device stack, and we'll see that it's actually also the case for your gateways. Everything that's deployed in the field, there's not necessarily the ability to send human beings to monitor and to interact or to fix any issues there might be. So remote headless management is actually very, very important. Jumping into the gateway stack, and I'll go through the three different stacks, and after which I'll pause so that you guys can ask questions if you have any. So on a gateway, what's a gateway? Well, I like to call the gateways a device on steroids. So like all in all, it's really taking all the functionality that was already part of a constrained device, but what we add really is the ability to manage our applications in a more global way, and like there's way more processing power on the gateway than there is on the constrained device. So essentially what the gateway provides is a container, a runtime for several applications to be deployed at the same time, in addition to the ability to do everything network management. So a typical gateway will be running several applications as opposed to one single monolithic application like we saw in the first stack, in the device stack. And this adds the ability to do network management. So basically taking data coming and using the built-in support for, again, just like before, CAN bus, Modbus, Bluetooth, Z-Wave, use this connectivity support for talking with constrained devices on the southbound interface, if you will, the local interface of the gateway, and then turn this raw information into meaningful messages that will be routed to the cloud, right? And have also all the capability to not only turn this raw information into meaningful messages, and that will be basically the role of the apps that you deploy in your gateway. But what's more, the gateway is smart enough so that if for some reason the connectivity to the internet is not super reliable, and that's very likely going to be the case in IoT, right? You're talking about a gateway that's maybe in a car, and the car goes yet all the apps collecting data from the different ECUs in the car, etc., will be collecting data, and the apps will be trying to send data to the cloud. Only it won't work because the connectivity isn't there, but hopefully if the IoT gateway is smart enough, it will have local persistence capabilities. It will be able to work offline, and as soon as the connection resumes, it will be sending the data again to the cloud, and it will be sort of transparent for the application that are running on the IoT gateway, right? So that's that's for the gateway. And moving on to the platform stack. Here we are probably talking cloud backend as usual, right? And we will be running our cloud bits on some kind of platform as a service infrastructure, and could be like pure just Docker, it could be Kubernetes, it could be Cloud Foundry. The idea is that we will want to basically deploy some services or microservices that are specific to IoT. First, and one will be around connectivity and message routing. Like, how do we manage the fact that there's going to be lots of different devices or gateways in the field sending data, possibly using several communication protocols, right? Maybe some data will be coming in as HTTP data. Some data will be coming in as ActiveMQ, AMQP messages, etc., etc. So ingesting and normalizing huge amounts of data into the enterprise backend is actually something that's fairly specific to IoT, right? And doing this at scale, right? Then will be everything device management and device registries, the ability to correlate this data that's coming in, to correlate it with actual devices and make sure that the data that's coming in really belongs to a device that's authorized in the platform, making sure that maybe also beyond the pure application data, also in terms of pure device management, have the ability to push firmware upgrades to our devices, the ability to have sort of to know what's our inventory like, what's our list of different devices, what software version they are running, etc., etc. This is also very important. Data management, like I said, we will probably have some kind of functional components that tell us that know how to ingest data into the backend platform. One consumer of the data will probably be our data management service, which will take care of storing the data, maybe processing the data, so that, like, to do data crunching, if you will, we will have lots of data points coming in every second. How do we store this data? How do we make it queryable for people to basically utilize the information? And probably at a higher level, once we have all this information related to the devices themselves, as well as the data they are reporting, well, we will start thinking in terms of complex event processing, event management, providing some kind of user interface in the form of dashboards, graphs, so that to allow operators of the solution as well as third parties, essentially to interact with our IoT fleet. And last but not least, and probably slightly outside of the scope, of the platform itself, like it's likely that our IoT cloud platform will provide a UI of its own and like data visualization of its own, but it's also about not making any assumptions on how the data that we collect will be utilized and like exposing this data to third parties. So any IoT cloud platforms should expose APIs to enable application integration, right? And not necessarily thinking or talking about open source at all. If you think IoT platforms or such as AWS IoT, Azure IoT Hub, or IBM Watson, or essentially all the other IoT platforms out there, obviously they all expose APIs because there's just so much that you can do from the UI that the cloud provides and the platform provides, right? At some point, it's going to be up to third-party application developers to tap directly into all the underlying services so that to utilize the data the way they want. Are there any questions, comments at this point on the three stacks, or essentially on anything that I mentioned just before? And I will also use the opportunity to briefly disable my notifications so that we don't get polluted, and especially since I think this is recorded. So let's turn on, I think I can do it from here. Can I? Any questions, any comments?
Yeah, Benjamin, in meantime, I would like to ask for some people from Obstacle, what do they think Obstacle should be concerned more about, the lower stack, the central stack, or the cloud stack, or three of them, or two of them? What do you think, guys?
I think, like in architecture workshop in Stuttgart, the most of the time we were focusing on that in-car stack. So that's natural that most of us are focusing on in-car.
So the in-car, you consider the in-car as a gateway?
Yeah.
Yeah, the gateway.
Or the southbound from the gateway.
And gateway to the cloud.
Yeah, or the southbound, not the connectivity part.
Ah, okay.
And that's why I think the challenge will be also to see the importance of the connectivity.
Okay.
If you think IoT cases, it's quite normal that we think that we have the connectivity, we have Ethernet, we have the kind of internet access, but now automotive is mobile, so we are moving all the time. So the most of the connectivity is based on that 3GPP. We have GSM or LTE or 5G connectivity, and in some cases vehicle to vehicle. So that will be interesting to investigate that.
Okay. Thank you. So please move on.
All right. So that would be for the three stacks, and like I was telling earlier, there's also some cross-layer concerns, namely security. So I mentioned like security at the hardware level, sort of like making sure that the code running on the device cannot be tampered with and cannot be altered by someone who would have access to the device physically. Security in terms of who has access to what in terms of the data that we collect, etc., etc., the ontologies, but we'll essentially see that later on. But everything data semantics, we collect large amounts of data. How do we make sure that there is some common understanding of what the data is all about, and the tools in terms of how do we develop the solutions, how do we test them, debug them, simulate maybe some of the different IoT services as part of the end-to-end development chain. So that's something that we will see later on. So all in all, like I said, we went through sort of the mental exercise of identifying what are the three stacks for IoT. What's even more important, I think, is to make sure that they are open. What do I mean by open? Is essentially try to fight the issue that we've had and we still have to some extent with IoT, where all the IoT solutions are essentially siloed, right? You have a Nest thermostat from Google, and it's very likely that you won't be able to use this smart device with anything else but the cloud backend that Google wants to give you, right? So how do we, and you won't be able to use this device with any other protocol than the one protocol that it's been designed for, right? So with open IoT stacks, on the other hand, you have a way. You start thinking in terms of loosely coupled stacks, right? You could use, and you should be able to use a gateway running, say, Eclipse Cura, which is our one of the open source projects from Eclipse. Ideally, you can use this gateway stack, which with whichever cloud stack you'd like. Could be IBM's, could be Microsoft's, could be maybe an open source one. It shouldn't really matter, and there should be some clear interfaces that allow to combine essentially each stack with any other stack. Modularity should also come within the stacks themselves, like all the different functional blocks that I've identified before. What does it mean? Well, it means that within your gateway stack, out of the box, maybe there is support for protocol A, or rather say MQTT. Should you want to replace the default protocol implementation that your gateway supports, to add another protocol or to replace the supported protocol with something completely different, this should work, and this shouldn't impact the other components of your gateway. Typically, the apps that run on your gateways, ideally, they're not impacted by the choice of a different protocol, and this is what modularity is all about anyways, right? Modularity and independence as well of the underlying platforms. I was mentioning the hardware abstraction layer for constrained devices. That's one. That basically means ideally we can run our constrained applications indifferently on ARM and on Intel, maybe, but it should be the same for maybe for the cloud as well. If you start developing cloud modules against your open IoT cloud microservices, well, you should be able to move from Amazon to Google Cloud to private cloud, ideally without any issue at all. You want to have this independence, otherwise this is the silos all over again, and you start building a cloud solution on AWS, on Amazon, and you're stuck with Amazon forever, unless there are some open APIs, open standards that basically enable modularity. And history has proven and has shown that open source helps in that regard. And this, if you look at how the internet is built today, the internet is built on open source, right? And Linux, Apache, MySQL to some extent, although it's less and less the case maybe, but they do run the internet. And long gone are the days where like people were trying to sell you servers, like internet servers and WebSphere and whatnot. They're all gone now. All the enabling technology for internet is all based on open source, and you have flexibility in terms of where you effectively want to run this whatever you build on top of this infrastructure. So trying to come up with open IoT stacks and open IoT software is something that we've been doing at Eclipse for the past 6 years. So we are essentially an open source community that not only provides the collaboration model for people to build the software, and we have something like 30 different open source projects for for IoT, and we also have the place where people can collaborate not only on the software itself, but on the use cases, etc., etc. So that's our membership. So like I said, we are a community. So 30 different open source projects being worked on by the likes of Samsung, Red Hat, Sierra Wireless, Bosch, Deutsche Bahn recently joined, and that's and there's more joining week after week. So those guys, those people, they use Eclipse as a place where they can work together on on any component essentially that they see as a commodity in IoT. Like, let's not fight on or let's not try to reinvent IoT communication protocols all day long and try to figure out how to differentiate at that level. There's just no way to differentiate there, and quite the opposite actually. It's actually all those companies, they realize that it's important to agree on a set of good protocols or like have good compromises in terms of what IoT communication protocol should be, and collaborate on providing good open source implementations of those protocols, so that to maximize the number of adopters of the technology, to maximize also the variety of implementations. Like, providing open source implementations is a good way to encourage people to come up with maybe different implementations in different programming languages, and to basically give developers choice in terms of choosing whatever implementation they feel the most comfortable with. And so, looking at the technology now, if you've been sort of following what's been going on at Eclipse since day one, we used to tell this story where Eclipse IoT would be the place where you can download the building blocks of your IoT solution. Would you want an implementation of the MQTT communication protocol where, well, you could basically download code from Eclipse Tahoe or from Eclipse Mosquito to get clients, to get servers, to do your MQTT stuff. Same for lightweight M2M protocol, same for doing connectivity, etc., etc. And those building blocks are certainly still there, but the over the past year, mostly, and certainly more recently, even more recently, we are headed towards more integrated stacks that people can basically take as is and start deploying in their own devices or gateways or clouds, as opposed to having to figure out how to take all the different building blocks and make them play well with one another, right? So for devices, quite frankly, we're not there yet in terms of having an integrated stack. Yet we have several building blocks, several components that people already start taking and start using with one another to build their own stacks. But there are still lots of fragmentation in terms of the architectures of the constrained devices and the capabilities, etc. So it's kind of hard to provide a ready-to-use operating system, if you will, for or full-blown distro for constrained devices. So we have still 3 interesting building blocks. One being Eclipse Edge. So that's actually taking care of the hardware abstraction layer. Basically provide a high-level abstraction of all the APIs you would find on a microcontroller for doing interacting with the GPIOs, for interacting with the underlying flash storage, etc., etc. So it's called Eclipse Edge, and I'll have a couple more charts afterwards to dive a bit more into what it means and what it is. Eclipse PAHO provides an implementation of should you want to run the MQTT IoT protocol on your constrained devices. PAHO certainly has such an implementation. And in terms of remote management, Eclipse Wakayama is a C implementation of the lightweight M2M standard, which essentially standardizes what it means to do remote management of a constrained device. What does it mean to do remote firmware upgrades? What does it mean to monitor the battery level of a device? What does it mean to monitor remotely reboot a device? That kind of stuff. So that's Eclipse Wakayama. A few more words about Edge, like I was saying. Eclipse Edge is an hardware abstraction of everything peripherals, everything IOs for a device, and it's in Java. So essentially, you would run Java applications on top of those APIs, and essentially the actual Java virtual machine could come from Oracle, could come from OpenJDK, or if you're looking at even more constrained implementations, Azure systems or a company called MicroEJ do provide such constrained implementations that that can basically implement the APIs that Edge delivers. In terms of how small a device running Edge can be, these are the figures. So this is maybe not as small as the smallest Arduino, the Arduino Uno. I'm pretty sure it's close to the Arduino Mega sort of specs. So it's still a fairly small device, a Cortex M3, Cortex M4 kind of device. Moving on to gateways, and there's certainly a ready-to-use stack from Eclipse IoT. Several actually, depending on what kind of gateway you're looking at building. Should you want to build kind of general purpose IoT gateway, Eclipse Cura is your is where you will want to look. So you can take Eclipse Cura and install it on any kind of Linux gateway. So running either CentOS, Fedora, Debian, any kind of Yocto-based distro. And the idea is that Cura will provide you with all the APIs and the functionality that we identified earlier, not only for enabling application development by means of providing an application container for Java code in the form of basically leveraging the OSGI standard. And on top of OSGI are all the services for interacting with IoT devices using an out-of-the-box. Cura will come with support for Modbus, Bluetooth Low Energy, OPC UA, CAN bus, serial-based protocols. So this comes built into the framework, and basically on top of the support for these protocols is also the support for communication with the cloud. So it's very focused on MQTT, although you can use other protocols if you'd like. But essentially what happens when you start having built-in protocol for so-called field protocols for basically the interaction with the devices and built-in support for interaction with your cloud, well, essentially the apps that you can start building will leverage this functionality, and your apps will be probably fairly trivial code that you will write to take data from the field, route the data to the cloud, maybe do some local pre-processing. And that's what Cura will do, in addition to providing everything that's needed for remote management. So not only management in the form of a web interface that anyone can use for managing the equipment, but also APIs for managing the devices remotely, like from the cloud. If you want to deploy new software upgrades, etc., you can certainly do that. So that's Cura, and that's sort of a deeper dive into the architecture of Cura. All the built-in services that I was describing earlier is slightly smaller granularity here. The important aspect will really being that it can be ported on many kinds of hardware. The only requirement is really having Linux on the board, and then yes, the web UI, the web interface, as well as the headless sort of interface, and the ability to deploy as many applications as you want, and they all run in their own sandboxes, which is quite important when you do IoT, right? Any questions on either the device stuff or Cura at this point? Okay, so moving on to another option when it comes to running a stack on your gateway. Another interesting open source project at Eclipse is called Eclipse Smart Home. So it's Java based as well, and there it's more targeted to a specific vertical in the form of home automation, and basically when we will talk about connectivity and protocols for smart home, this will be all the protocols that you would find in home automation, right? The likes of Philips Hue, Wemo, and Ocean, etc. would be protocols that are supported natively by Eclipse Smart Home. And in terms of messaging, it's not really about routing data from devices to the cloud, but rather from devices to other devices, and more having the ability to have a rules engine for doing things like, if temperature in my bathroom is above 25 Celsius, then turn on the air conditioning and stuff like that, right? So that's that's kind of how Eclipse Smart Home works. In addition to having nice, well, it has a very nice graphical user interface, a very nice set of APIs for interacting with the framework using text-to-speech or speech-to-text to control the devices. And all in all, you should really think of Eclipse Smart Home as a 100% open source implementation of either like Amazon Echo or Nest from Google, in a much more open way, in a much more extensible way. So that's Eclipse Smart Home. And then we'll start moving into the cloud side of things, and starting by sort of the building blocks that are available for building the cloud, and trying to see what's missing from there to a more complete stack. We certainly have many interesting building blocks for building the sort of the IoT microservices for the cloud, around device management and device identity, device registry. One is Leshen. So Leshen is really for device management in the form of providing the server-side implementation of the lightweight M2M protocol, so that you can have a way from your server to push firmware upgrades to the field and stuff like that. And Eclipse Hogbit is actually a layer below, in that it's not really about effectively managing the devices. It's more about, and it's not about effectively sending instructions to the field. It's more about being able to describe what's the software that all your devices are running, what's your list, what's your inventory like. And at some point, Hogbit will be able to sort of model what are all the dependencies between all your different software components in your IoT systems in the field. And maybe a protocol like Leshen or a server implementation like Leshen will effectively ask Hogbit for instructions on how it should perform effectively the upgrades. But Hogbit is really more about just describing the different scenarios for your upgrade campaigns, describing things like, I have 1 million cars for which I need to update the software. I certainly don't want to push 500 megabytes worth of firmware to my 1 million cars at the very same time. I want something like Hogbit to be able to describe a software upgrade campaign in the form of, okay, let's try and update the million cars over the course of the following 30 days, right? And if for some reason the upgrade campaign fails for more than 0.1% of my equipment, then stop the campaign altogether. And then what's going to happen is that if my devices are managed through lightweight M2M, maybe Leshan will be effectively talking or will need to interface with Hogbit, so that to ask Hogbit, hey, are there any devices you want me to update? And then Hogbit will start providing this information, and maybe if there's 1 million devices, well, if you start the campaign, it will start by just instructing Leshan to just update the first 2 or 3% of the fleet on the first day, etc., etc. So that's for device management. Your devices to this sandbox, and that's sort of the overview of Hogbit, with the ability to manage the repository of the devices and the software they're running, the ability to do also the actual storage for the artifacts, for the binaries that you want to update. And Hogbit will be able to do things like, if you have devices that you want to update in Brazil, well, maybe you want the actual physical, the actual software artifacts to be hosted somewhere on a server that's close enough to South America. So I hope it can do that, do sort of a content delivery network for IoT software artifacts, and will manage all the rollouts, etc. And then the integration will come by means of writing software update agents, if you will, that will talk to Hogbit to figure out what are the things that need to be done, and effectively do them and do the updates by means of talking a specific field protocol. In terms of connectivity, would be Eclipse Mosquito. So that's basically, should you want to ingest data into your IoT backend, and you have devices or gateways that talk MQTT, chances are you can use Eclipse Mosquito, and just out of the box it will provide you with a broker for the MQTT protocol. It's meant to be really scalable. The footprint is really minimal in terms of memory. Like 1,000 clients will just eat up 3 megabytes of RAM, so that kind of tells you how easy it is to scale Mosquito. It's a C implementation. It's also meant to be very extensible. So that's great. I mean, I've covered some of the sort of building blocks that are available for building your cloud. But you may start realizing that in terms of integration, it might not be ideal. Like, yes, we do provide sort of a building block for ingesting MQTT data, but it's just a broker, right? It gets MQTT data and routes the data from point A to point B. It certainly won't take care of storing the data out of the box. So either we require an additional building block for that, or maybe a more complete and integrated platform. Same for ingesting more than MQTT data into my backend. I'm not sure that's what I was covered in what I just said, right? Or even more so, what if I want a multi-tenant solution? I want to make sure that data that comes into my backend platform, I'm able to figure out whether it comes from customer A or customer B, because I have strong requirements of making sure that the data doesn't end up in the same data center when it comes to effectively storing the data, processing the data, etc. So this is where essentially you need a more complete cloud platform, and that's what Eclipse Kapua is all about. So Eclipse Kapua is the definition of all the microservices that are required for IoT clouds. So what is a device registry in the first place? What is an IoT data store? What does it mean to store an IoT data point? what's my telemetry information like? Are there when information is being sent by devices, how does it look like? Are these strings, integers? What kind of information do I support? So that to make sure that I have a consistent representation in my backend, so that all my services can basically start communicating with each other, right? If I start storing data into my backend and probably some kind of NoSQL data store, I want to make it in a way that I expose an API that my dashboard will be able to use, or that my APIs will be able to serve. So that's what Capua does. It describes all the APIs and then provides implementation of those APIs. So for example, when Capua provides the description of what an IoT data broker should be, this is something that Mosquito can be an implementation of, or maybe this is something that will be implemented in the form of AMQ for the broker, or maybe yet another kind of broker. Same for the data store. By default, Eclipse Capua provides you with an implementation of its data store based on Elasticsearch. But if for some reason you want to use another kind of implementation, you certainly can do that. But the important aspect here is that there is one consistent description of all the services you may expect to find in your IoT backend, so that Capua knows about them all. And for example, the console and the UI in Capua federates all the other microservices to provide you with a nice consistent UI where you can see the list of all your devices and your device inventory, where you can start pushing new upgrades to your devices, when you can start seeing all the data coming in from the different devices, etc., etc. So that's what Capua does, and it's also designed with, of course, with scalability and cloud-first concerns in mind, which means that you can run Capua on OpenShift, on Kubernetes, on Cloud Foundry. It really doesn't matter much. You can also run on your own private cloud, but the important aspect is that should you want to scale up your the data management aspect of Capua, well, you can start firing up new instances of your Capua data store, and you will start scaling your cloud platform that way. In terms of data connectivity, actually, the way so it's not right now, this is not how the connectivity microservice of Capua is implemented just yet, but in the next few months, the Eclipse Hono project will be integrated in Capua. And essentially the way it works is that Hono is a microservice that you would deploy in your cloud, so that you can easily create different protocol adapters that are basically the front end for your devices. And so maybe devices will start talking MQTT, other devices might talk OMADM and whatnot. And Hono basically takes care of the protocol adapters, feed the data into the Hono instance. So translate basically, protocol XYZ to AMQP, the AMQ protocol, and basically what Hono takes care of is federating all this telemetry information into one single common representation. That's again AMQP, so that your own application, or more generally your Capua backend, can take this data and understand basically what's been coming from a wide variety of devices, and have one single common representation of the data, store the data in the data store, correlate the data to maybe information in the device registry. And that's really the scope of Hono, with actually lots of contributions from Bosch and Red Hat to this project. More sort of a high-level overview of Capua, but that's sort of paraphrasing what I just said already. You can see maybe more details around what Capua can take care of in terms of device management. Some of this would be actually taken care of by possibly by Hobbit in terms of an actual implementation, and or you can provide alternative implementations if you'd like. Same for data store. I was telling that a default implementation of Kapua would rely on Elasticsearch. If you have your own storage engine that you want to bind to the Kapua APIs, you can certainly do that. So in terms of where we'd like to go in terms of sort of an integrated architecture, this is how it could sort of look like. How do you take Kapua and integrate Kapua with all the different pieces, with Hono as the connectivity layer, with possibly protocol adapters for lightweight M2M, for Mosquito, etc. I'll skip on this slide. I think it's not necessarily 100% up to date, so I should have probably have removed it from the deck actually. Now moving on to more the cross-layer concerns, like beyond the purely the three stacks, there's, like I said earlier, security concerns, data semantics and ontology concerns, as well as tooling. Around security, what do? We have Eclipse Kitty, which is a project contributed by General Electric, GE Digital, from the Predix platform. Essentially, it's taking OAuth in terms of authentication and authorization, and taking that to the next level in terms of IoT. More specifically, it's the ability to model what are the different roles that someone or some entity might have in an IoT solution, and associate those roles to access rights to data, right? So, for example, the ability to say that all the data analysts in my solution have read access to temperature information, then maybe the ability to say that people located in the Helsinki office have right access to weather information, and then maybe at some point the ability to tell that John is a data scientist based in Helsinki, so that would be like kind of the different roles this John guy would have. Then what does it mean in terms of data that he has access to, right? And the ability for John to request a token, an authentication token against the cloud backend to start doing stuff on the data, and either have read access, write access, or all kinds of authorization on the data. So it's a very interesting proposal, and it's very well integrated in platforms such as and in frameworks such as Spring Security, so that people can easily leverage the different rules in their existing backend systems. Data semantics, Eclipse Vorto provides a very interesting approach to describe the capabilities of IoT devices. So a Vorto information model describes the capabilities of sensors, devices, etc. And then by means of code generators, people can easily turn this representation of the device capabilities into something more meaningful, like generate some code that will use like some code, for example, to start manipulating the device within Cura, or some code that will be a very default, very simple UI for interacting with the device through a web interface that relies on the Kapua APIs, for example, right? That kind of workflow is something that Vorto provides. And there is an online repository hosted at vorto.eclipse.org that people can populate with their own information models. People can add their own code generators. So over time, we expect this to grow and to start supporting more devices, more use cases. And yeah, something that I certainly encourage you all to have a look at. In terms of tools, although we're Eclipse, and you can think of Eclipse as a community that does a lot around tooling, we don't have that many tools actually available from our portfolio of projects. Yet, if you're interested in tooling around MQTT, I certainly encourage you to have a look at MQTT Spy within the Eclipse PAHO project. So it's a tool for simulating MQTT data, for subscribing to an MQTT data broker to visualize the data. You can actually display data in the form of charts. You can record a live MQTT data stream so that to do post-mortem analysis, maybe replay the data later on. You record 1 hour worth of IoT communications, and you can save that locally to either go through it manually or to replay the data later on to reproduce an error case, maybe stuff like that. So that's for the technology. And before opening up to question, I want to make sure that I give you also a fair coverage, sort of what we do beyond purely the code. So yes, we have lots of code, 30 different projects that add up to 2.5 million lines of code with 250 plus different developers that over the last 12 months contributed code to the different projects. Lots of people accessing our web properties, and we do actually more than just code, right? We also organize initiatives for developers. We want developers to start becoming more familiar with some of the technology that's required for IoT. So we've been running developer challenges 3 times actually, where we basically award the best, most innovative IoT solution with prizes like cash and hardware. And so people build really cool stuff. This year we had someone build a tracker for sleep analysis sensors that would figure out the activity of someone during his or her sleep, and using this information and do machine learning and artificial intelligence to basically identify some patterns in the way people sleep, so that to help cure bipolar disorder, and basically based on specific patterns, anticipate on a new episode, if you will, of a bipolar phase. So that's basically something that they built using Eclipse PAHO, Eclipse Mosquito, Eclipse Cura, and that's really cool stuff. We also do webinars. If you don't know about the Virtual IoT Meetup just yet, feel free to have a look. There's all the recordings of the past sessions, as well as whatever we have in the pipe for future webinars can be accessed from this URL. If you want to learn more about some of the projects that I've mentioned, chances are we've already done a webinar with the project leaders in the past, so you can go and check out what the resources online. There's really a lot. And when I mean a lot, that's what I mean. Like, there's really lots of videos that you can check out. And I think that's basically what I had. We have plenty of time for questions. If there's one project in particular you would like more information about, feel free to let me know. Any additional information you require about the projects, our website is certainly the place to go for downloading the code, downloading tutorials, etc. And I think that's what I had.
Thank you very much, Benjamin. Any question for Benjamin? I have a question, Benjamin, about the level of documentation on each of these projects. What we can expect? Is it almost at the same level, or do you have more recent project with less documentation? How does it work so far?
So your last sentence is actually not necessarily true. That's I guess it would be natural to think that way, and a new project would be maybe less mature in many regards, including documentation. However, what we see is that more and more the Eclipse IoT projects, they are actually contributed by companies that use them for commercial products of their own, right? And if you look at the documentation of Eclipse Hawkbit, for example, it's actually very complete, and the reason is Eclipse Hawkbit is pretty much 90, well, I wouldn't know the exact amount, but a lot of what's available in Bosch's IoT rollouts commercial product is effectively Eclipse Hawkbit. So all the documentation of the APIs and how to integrate with Eclipse Hawkbit is essentially the same documentation that Bosch has built for their commercial product in the first place. So the documentation of that particular project is very professional and very complete, and probably way better than you would expect from many other open source projects you may have stumbled upon. And this is also true for projects like Eclipse Cura or Eclipse Kapua, that are actually projects that are being used commercially by companies like Eurotech or Red Hat. So the documentation is actually very, very mature. Some other projects might be less documented, or like you might, certainly not the same level of maturity. So it's like, I mean, I would be happy to sort of give my level of sort of confidence regarding the maturity of the documentation if you guys have questions on such or such project. But yeah, the ones I just mentioned, in terms of maturity and documentation, they are actually pretty advanced.
Okay, thank you. Another question? Okay, thank you very much, then, Benjamin, for your presentation. It was very interesting.
Thank you. So you guys have you have my contact info. Any follow-up questions, feel free to go through Philippe or to ask me. I'd be happy to point you to relevant projects or to people also. We can answer questions you may have.
And please send me your presentation like that. I will be able to put and to share it on our internal Abstacle website with the rest of the people.
Sure, will do.
Thanks a lot.
Thank you.
Thank you.
Bye-bye.
Bye now. So we have a last presentation, which is mine, and we'll be done with the day. So normally this presentation should start. It was supposed to start now.
In 55 minutes.
55?
Yeah. So finish time 15:45.
15 minutes for 55 minutes. So in an hour. So should we wait for another hour to run it? What do you think? Or should we take just a small break and then move on?
Yeah, if that is possible, we can take just 15 minutes break and
continue. Okay, let's do that. And we will be back.
How about the others? Is it okay that we take?
If you're not okay,
it's okay. Yes, it's okay.
Okay, thank you guys.